All right, finishing up our section on complex numbers or imaginary numbers. We're going to skip over to example 5 on page 31, and we're going to look at how to factor a sum of squares. I can factor a sum of squares. So now let's go back and review how to factor a difference of squares first. So before we had something like this, x squared minus 16. And if I wanted to factor that, I would start with my two sets of parentheses, and then I would take the square root of x squared, and that would be x, so I'd put x and x here. My signs were always plus and minus. And then I take the square root of 16, that's 4, so 4 and 4. And that would be the factored form of x squared minus 16. So now we're looking at a sum. So instead of a difference, so instead of subtracting, it's going to be adding here. So that's what we're talking about, factoring a sum of squares. So let's write down our success criteria. As always, with all factoring, you always need to check for a GCF first. So check for a GCF first. So I'm looking at x squared plus y squared. X squared and y squared don't have a GCF, so I can go on to my second step. And I'm going to rewrite this sum as a difference. So rewrite as a squared minus negative b squared. So how can you write a sum as a difference? Well, you can say minus a negative, because minus a negative is a positive. A negative times a negative is a positive. So I can say x squared minus negative y squared. This is the same as x squared plus y squared. Minus a negative is the same as a positive. All right, now this is a difference of squares. So if I take the square root of x squared, that's just x, and then my minus says I write the signs plus and minus, and then the square root of negative y squared, that's like saying the square root of y squared I. And then the square root of y squared is y. So this becomes yi and yi. So it follows this formula. So follow the formula. So I have a squared plus b squared. It always will factor out like this. A and A, plus and minus, bi, bi. So let's see if that's true here. So square root of a, so that's where the a and a come from. So square root of x squared, x and x. And then the square root of the second term is bi, bi. So yi, yi. So see how it follows this formula right here. All right, let's look at another one. So I'm going to look for my GCF first, and this one does have a GCF, and it's 3. So I'm going to factor out my GCF first. So take out a 3, and you're left with 4x squared plus 1. And this is the same as saying 4x squared minus negative 1. So I'm going to follow the formula a plus bi, a minus bi. So the square root of 4x squared is 2x, plus and minus. And then the square root of negative 1 is 1i and 1i. There's your answer. All right, pause the video and try those additional examples at the bottom there. Okay, let's check your work. No GCF here. Oh, I forgot my x squared. It should be 4x squared. Take the square root of that. That would be 2x and 2x. Plus and minus are my signs. And then 5i and 5i. Okay, this next one does have a GCF. The GCF is 2, so I'll take out a 2 first. Bring down my GCF. Rewrite it as a difference there. Bring down my GCF. Square root of 4y squared would be 2y. And then square root of negative 9 would be 3i. So plus and minus, 3i, 3i. Final answer. All right, so that's factoring a sum of squares. So yesterday, let's backtrack a little bit. Yesterday, we did adding, subtracting, and multiplying these complex numbers. So what we didn't talk about was dividing. So let's do that now. Let's go back. All right, going back to page 29. Okay, so we're gonna start down here where it says complex conjugates. So when you're dividing, you have to multiply by what is called a conjugate. So a conjugate is, so say I was given 7 minus 8i to start with. The conjugate would be 7 plus 8i. So the real number stays the same, just you change the signs for the imaginary. So instead of minus, it became plus here. So notice how the signs are changing. Everything's staying the same except for this middle sign here. So negative 2 plus I becomes negative 2 minus I. So these are conjugates of each other. All right, so how does that apply here? Let's turn the page. So now let's look at division. So I can simplify a quotient with complex numbers. I can simplify a quotient with complex numbers, or basically I can divide complex numbers, okay? So the first thing you're going to do is determine the conjugate of the denominator. Determine the conjugate of the denominator. So let's go down here. Here's my first example here. So I'm given 80 over 2 minus 6i. So I'm looking at the denominator. My denominator is 2 minus 6i. So I need to figure out the conjugate of 2 minus 6i. So the conjugate would be 2 plus 6i. Remember, you just changed that middle term there. So 2 plus 6i is what I'm going to multiply to the top and bottom. So that's your second step. So after you figure out what the conjugate is, then you're going to multiply top and bottom of your fraction by the conjugate. All right, then at this point, once you have it set up, like we do here, now you're going to either distribute or FOIL. All right, so let's look at our problem. So on the top, I'm gonna do 80 times 2 plus 6i. So this is going to be distributing. So I'm gonna do 80 times 2, which is 160, and then 80 times 6i, which is 480i. Then on the bottom, I'm going to FOIL. So I'm going to do 2 times 2, and then 2 times 6i, and then negative 6i times 2, and then negative 6i times positive 6i. Remember, I times I is I squared. Don't forget about that. All right, now I'm ready to simplify. Move this up a little bit. Okay. So the top, you can't simplify any further. That's good to go. But on the bottom, I'm going to change this I squared to a negative 1. And then I see that 12i minus 12i, those cancel each other out. So I have 4, this is minus 36. And replace that I squared with negative 1. So this is like saying 4 plus 36, because negative 36 times negative 1 is positive 36 there. Four plus 36 is 40. Okay, so now I have it simplified as much as I can. So my last step is to write my answer in standard form. So step 5, you're going to write your answer as that a plus bi form. So how do we do that in our problem? Well, we're going to start with our a. So our a is 160 over 40. And then our b is 480 over 40i. Then I'm going to see if it can be reduced, and it can. 160 divided by 40 is 4. And then 480 divided by 40 is 12. And then I. And then that is your final answer. All right, pause the video, try B. Okay, let's check your work, see how you did. So first you need to determine the conjugate of the denominator. So that would be negative 1 minus 2i. We just changed that plus to minus. Then I'm going to FOIL the top, and I also need to FOIL the denominator. Okay, so I do 4 times negative 1, it's negative 4. 4 times negative 2i, it's negative 8i. Negative 3i times negative 1 is 3i. Negative 3i times negative 2i would be positive 6i squared. And I'll FOIL the bottom. Negative 1 times negative 1 is 1. Negative 1 times negative 2 is positive 2i. 2i times negative 1 is negative 2i. And then negative 4i squared. All right, now I'm ready to simplify, so I'm going to replace my I squareds with negative 1s. And at the same time, I can add my i's here, so that would be negative 5i. Those cancel out. Replace that negative, or that's I squared with negative 1 here. So 6 times negative 1 is negative 6. Negative 4 times negative 1 is positive 4. Then I'll do negative 4 times, or not times, but negative 4 minus 6, which is negative 10. And then 1 plus 4 is 5. All right, simplified as much as I can. Now I'm ready to write my answer in standard form. So that's negative 10 over 5 minus 5 over 5, I. Negative 10 divided by 5 is negative 2. Those cancel out, so minus I. Negative 2 minus I would be the answer. Also, if you wrote negative 2 minus 1i, that would also be acceptable. Okay, so that concludes our lesson for today. Now you're ready to work on your worksheets.